Hello guys, in the lab of exceptional confirmation, the goal is to have a separation of concern, basically making our airplane class decoupled from any exterior classes, such as, in this case, the biggest thing being system.out.println. So in today's correction, we're going to talk about that. We're going to talk about the goal of this, and we're going to go over a few ways to optimize our code, and lastly, some feedback from the labs I got, and I've seen some major issues, that pitfalls that normally you would do at the beginning levels. So let's get started. The first thing we want to kind of understand is our naming styles. Public class airplane, public void start engine. So the moment I'm going to do airplane start engine, that's the only thing I'm expecting it to do. Nothing more, nothing less. It shouldn't go and do something unexpected, and it should give me enough feedback so that I understand utilizing this method, everything's going out smooth. And this is important because we create a trust between developers, one to the next, that are there are methods and classes are made so that they function correctly. And again, they don't do anything unexpected. The same way you start doing system.out.println, you expect it to print out to the system out, which in this case would be the console. If it goes and creates a log somewhere and you don't know about it, this is pretty bad, right? So the naming style is really important. Even though back in the day, these standards weren't there and the language has been evolving over time, we still need to stick to these standards because they make our code much better, they make our colleagues much happier, and it makes unexpected issues not rise, right? So when we release this to the client, it won't have something unexpected or something not wanted. Okay, so we're going to do the same thing with our airplane class. You got to remember that when we utilize all these methods like this, or let's say the scanner, where's the scanner? Here we go. I did another class. When we utilize all this stuff, we expect it to do what it does without really reading the code, right? You guys utilize this code, the IO, to get the int. Who cares? It's a scanner, get int, doesn't really matter. The fact is, we utilize it without reading the code. And this is a must because we can't just go ahead and read everyone's code every time we're going to develop something. It's hundreds, well, not hundreds of years, but there's at least 30 years of coding libraries that's been getting bigger and bigger and becoming some day-to-day use, right? It's the same as saying whenever you get your car, are you going to go inside your car to understand it completely, that it does what it does? No, you have a certain trust in it. And this is the same thing here. So we got to make sure that our airplane class that we created, when it does start engine, it only starts the engine. It doesn't do anything weird. Don't expect it to do anything weird. If it does anything weird, you make sure you add it inside the name so that the name says it all. Sometimes it is possible that the name doesn't say it all. In those cases, we add a little bit of feedback inside the Java docs. We'll come back to that in the future. But really, good practice, best coding style, good code would be the name says it all, right? So again, our two goals were clean code, and the second goal was separation of concern, which we're going to do here. Now, to be able to do this implementation of removing the text, and again, one last time, I'm just going to repeat, our airplane should only deal with airplane, right? The output could have been to the console. It could have also been to a virtual reality or GUI or something. It doesn't really matter. So we want it to be separate. Now, if we go inside our airplane, we notice that most of the, let's say the start engine as an example, most of the actions in there, or most of the cases, it's about errors that happens. You notice we have exploded, that's an error. Flying engine ungrounded, that's another error. You could just see the text here that we put. We got another error, and that's when something wrong happens. This is mostly like something that hasn't been implemented. And lastly, we got our correcting, which is here. Now, how do we know the method is done correctly? Well, if it doesn't throw any errors, then we expected that it functioned correctly and everything went smooth. And this is what we're doing with exceptions. Now, let's get started on creating an exception. So here we already have an exception, but one of the pitfalls I saw is some of you went ahead and created a class and called it, let's say as an example, called it text exception. I can't spell. And again, we're gonna go and extend this. So we're inheriting, or we're making this a bit more, we're adding features, whatever you want to call it. And you could decide with yourself if you want it checked or no checked. And again, don't forget, we want to overwrite the constructor, which would give us a message. So Control O here, Control O, and we're going to take the one with the message. We could overwrite pretty much everything if we want to, but this is good enough. So here we're getting a message. So now one of the things I saw was that they went here and they said, throw new text, oops, typed in too much, text exception. And here they put in those messages. Let me move some of my, there we go, it's good enough. So they went and they copied that, and we're going to remove this for now. So we're gonna throw another one here and another one here. And just wait 1 second. I'm just gonna copy this text message so that we know it's going to happen. And there we go. And we could delete the system.out. Now, because these are unhandled, because these are checked exceptions, so they need to be managed, handled, we need to go ahead inside our method signature and add throws with an S, and you could see the IntelliSense popping up. And we say what exceptions are possible from this location. Text exception. Now, the problem, well, a couple things. When a throw happens, you'll notice I got a error message on the break. This is basically saying this is unreachable code. And if we put our mouse over it, we could see that. Because the moment a throw happens, our method ends wherever it is. So if it happens here, it'll never reach the next line. It will end the method and it'll go back to the caller. So this is important for us because this break is not possible to reach, nor is this break, nor is anything after our throws. So we got to be careful with that. Now, the problem by having this text exception for all three types of errors, right? This text exception, and the only way for us to know what it is, we have to read this message inside of it. The problem with this is, let's go to the main. That's where our related problem is. We could even click on that. First of all, it says this method throws an exception and you need to manage it because it's not unchecked. So we could easily manage that either surrounded with a try catch, or you throw it to the next guy, which is a bad thing to do. Don't make it throw further down. This is wrong. We said it many times. Someone has to deal with this, otherwise it will crash the application. So coming back to here. This airplane, it started an engine and I got a text exception. Let's say I don't have the console and I'm going to print this somewhere else. Or let's say I want to print my own messages, right? The user of this airplane class is not the end user. It's the middle guy, the guy who's programming with your application, with your library. So I got your airplane class and this start engine is throwing in an error. But it says text exception. How am I supposed to know if that is because the airplane exploded or that it's because the, I don't know, what was the other one? Because the airplane is already on or it's flying or something, right? This doesn't tell me anything. And I can't read the message at this moment. The only thing I need to do, or I could do, is I could go and read your code and I have to unbinarize it. So let's say that's the incorrect word, but I can't read binary. So I have to bring it back, go through your code. And this is pretty simple code, but what if it was more complex? What if it was 40, 50, 100 lines? You're forcing me to try and figure out how your code works to just start the engine. And that's just not cool. What if whenever the airplane exploded, in my application, I want to restart the airplane. I want to make a brand new airplane, put it back in the same height, give the guy an error message, simulation failed, try again at the same height. Or if I wanted to give him lives, maybe this was a game and he could have 3 lives. Once it exploded, the next time he'll be fine, right? But you giving me as a text, I can't do any of those. Because here, I'm not sure which error message is until I do if e dot get the message, and then we got to make it compare it to some text message. So I have to come here and say, well, if this message is the same as this one, right? If it's the same as that one, well, now we could do something. Make airplane, let's say as an example, airplane equals new airplane, and we're good to go, right? We're resetting the airplane. But this is prone to errors. What if I forgot one dot? What if I didn't copy paste it? What if whatever? What if I didn't understand what that error was being thrown for? This is a bad class name. This would make you get fired, okay? So rather than saying text exception, what we're aiming for is not the message that comes with it, but the class name itself, right? When you look at many errors, actually, let's come back to here. This last one over here, this default that we have here, this is for a case that's not been implemented. If you notice for status, we got, sorry, let's go here. We got exploded, engine off, engine on ground, and flying. There's 4 status here that's possible. And we cover all 4 status, right? 4. Really, this default is there if a new status is in, but we haven't implemented, right? So actually, a better exception than this is throw new not implemented exception, right? New status found in, I don't know, in airplane. Or let's say new status found, okay, whatever your message is, in airplane status, let's say. Okay? Now, why would we ever want to use this not implemented exception? If we look at the code, if we hold down Control and click on it, notice that it doesn't have any exceptional variables or methods or anything. It's just a simple class, the same as ours, which gets a string and passes it to the upper class, to the base class, whatever that is. It doesn't do anything exceptional, but it's there to make sure that we understand when we get this message what the problem is, right? When an error gets thrown, again, we're going to have to add this here. Not implemented. Okay. And again, this line cannot be reached, so we could go ahead and just erase it. The purpose of all of this is so that when we get here and we get a problem with this, we could catch that specific error. In this case, we're going to do Control space, and it's not here. Not implemented exception, E or whatever you want to call it. So now, when this issue happened, the caller of the airplane, could manage it rather than the airplane class itself manages it. You got to remember again that the airplane is being used somewhere and you don't know how. You don't know where, why, how, what's their purpose or goal. You got to make your airplane class be able to work anywhere they are. That's the best practice you could do, right? So this not implemented exception, it's more like, so airplane class got a new status and it hasn't been managed. It hasn't been implemented. It hasn't had a case for itself. That's what it is. Now, in this case, this is not a good one because in this case, we're forcing the caller to manage it, and this is not a good thing. So here we could even create our own class, but this time we create one that's checked or unchecked. Okay. So let's get started. I'm gonna create a few of these classes, and then we're gonna expand on it to make sure that it makes sense. I'm gonna pause the video so I go a bit faster and you don't have to wait 5 minutes of me just typing stuff, okay? So I've added a few here for each error that I've seen, and I removed the text exception, and I added this not implemented airplane status exception. I'm going to talk about all these three things. So the first thing is the text exception doesn't exist. So here we have airplane, and we have, let's just type in exploded, and you could see the IntelliSense pop up. Again, the name, as long as it is, it doesn't matter because the IntelliSense will give us what we're looking for. So here we got airplane exploded exception. Remember, we have to put in our signature because these are all checked exceptions. Engine is already on, so airplane, engine, and you could see on and off here. Now the extra message in there, this is up to us. If we wanted to, this name says it all, and we could make it the job of the caller to deal with the message to be displayed. We're doing this as an extra thing. To be honest, if you read this, or if you read this name, there's really no significance value change. So we don't gain anything by having this, and we don't lose anything either. It's up to you what you decide to do. So if you want to go ahead and not have the message there, well, we could go ahead here and create an overload for the constructor. We could even do it with Control O and just have an exception like this, right? This would be just as fine. It's up to you which one you utilize, you do, and so forth, so on. So again, this we need to put in our thing. I don't want to use this execution control. Now the problem with this one is a checked exception. So we're making it the problem of the caller if, well, he has to deal with it, whatever the case being. But this is more like a development phase. This is when we develop our airplane class. So it's not the problem of the caller, but the problem of us who create the airplane class. So in this case, I'm going to make this an unchecked exception, which I created here, by making it extend the runtime exception, right? Rather than normally where we extend the exception, which makes it a checked. So now, if I do this part here, and I go and I say, not implemented, I forgot what the name I gave. There we go. Not implemented airplane status exception. Maybe even better than that, I think would be to put airplane beforehand. So I'm going to go ahead and rename, refactor, rename. By doing the refactor, it replaces it everywhere. I'm going to say airplane status not implemented. It sounds a bit better because it's part of my airplane classes, right? And it keeps with the airplane naming style I went with. So we have to keep going. And now you could see that here, the moment I added this, it does not cause any problem because it's unchecked. So no one needs to deal with it. However, if it does get thrown and it's during runtime, well, it's going to crash the application. But this is more of a development phase. It shouldn't ever be on the runtime. So again, just to be clear, means when we're developing, we would test this and we make sure we deal with this ever happening. To be honest, this should not be there at all because this will never happen because we test for it. But we'll develop as we go forward. So let's go check out this problem. Now, the problem that we have is we have two exceptions and we need to deal with them. So if we go here, I'm going to leave this text exception for a second. Actually, we're going to go ahead and erase this one. First catch we have is if our airplane is exploded. Now, I could do two things. One, I could put my own message. Airplane exploded. No actions possible. I was able to do that because I know directly what the message is. I could also go ahead and utilize their message by saying exception.getMessage. Either one would have been fine. But here I'm giving power to the caller. Do they want to keep my message or do they want to customize it and do what they need, right? The goal is to give them more power. So this is up to us. In this case, I'm a bit too lazy, so I'm going to use the message already in there. So that's one type of error. What else do we got? Exploded exception, and we got an engine on exception. We're gonna again do catch, and we're gonna give it a name for that variable. And again, we're gonna just do the, oops, I can't type in, and what did I want to do? Exception, get message. Now, in both of these cases, we're gonna see what the warning is. Both of these cases, I could see directly what my problem is. You look at that text exception, I have no clue. This is pretty bad. I'm gonna show you ways that we could merge these errors and deal with them and so forth, so on. So for now, we're just gonna erase that. And we're also going to check what our warning here is. So here it says the branch airplane engine on exception is the same as the airplane exploded exception. So one thing you could do is merge them. We've seen how we could have multiple things in one location by doing the pipe. We could also press this collapse that's given to us by our IDE. See, this is the little pipe I was telling you about. So this is one way of doing it. I like it, but at the same time, I don't like it. We'll come back and I'm gonna show you a different way afterwards. But for now, I'm gonna leave it like this. Or actually, why not? Let's put it inside of a pipe. So this type of class or this type of class for exceptions, if you catch it, put it in this variable and print out the message. So let's go ahead and do it for all of them. All right, so we went through each one of those methods. Start engine, we have 2 exceptions and one that's unchecked. Stop engine, 3 exceptions and one that's unchecked, and so forth, so on. I did all of them. Now, having all of that done, we also went inside our main class, and for each one of those choices, we surrounded it with a try catch. And you could see all exceptions are shown there. And now we want to optimize that code. Well, obviously we want to test it. So make sure we run it once or twice. Make sure the error message is still what we wanted because we went and copy pasted, changed, etc. Make sure it works as always. You can see here, we have a problem. Our exception is being thrown to the screen. This is not good. So when I take off, I'm getting an error. So this is why it's important that we always test out what's going on. So here, the problem is I went too fast and IntelliSense just did a print stack trace, which is good. It tells us where the error is, but not the message we want. So what I want is this message over here. So I'm going to go ahead and change all of that to this. Actually, I like exception word better. E is okay. Okay, I'm going to go ahead and change all of those, and I'll see you in a second. So we're back to testing after fixing those issues. And if I do 2 now, good. I got a good message rather than that stack trace, which is not what we wanted. Okay, so now we need to optimize our code because this try catch many times is really painful to read. So one thing we could do is we could pipe it. So we could collapse all those 3 things into one catch message. Why? Because we're utilizing the message that's already in there. And if ever we want to use a custom message for a specific one, well, we could uncollapse it, take it out of from there, make its own catch. So that's something we could do. Let's do that quickly. You could see that we could collapse as many as we want, and they're all going to print it out. And this is the first way of making this a bit cleaner. It's not the final way because this is nice, but it's still a bit too much for the eyes. I'm going to show you a couple of things. Now that we see this, you notice for each case, we're just repeating the same thing. Try, catch, and when all the switch is done, we come back inside our while loop, we start it again. One thing to note about these switch cases, each one of them have a break. So after the case is done, we're done with the switch. So rather, this is a bit of thinking, rather than doing a try catch for each specific case, we know that they all have the same type of errors. why not make a try catch for the whole switch? Remember, actually, well, we're gonna do this first. Remember that every time, no, actually, I wanna pause. I forgot one thing. Again, we didn't test out fast enough. It's because it's already been like over 25 minutes of recording. But one thing we forgot is to say that something went correctly. Notice here, I got for errors, such as, let's say, if I start the engine again. Did I press something wrong? Okay. I pressed too many ones. So if I have an error, I showcase it. But if I do something correct, we're not giving feedback, right? This one worked, but let's say if I decrease, and I think these are working. Oh my God, I did another mistake. Let's go back to our airplane. Let's look for those system.out. So this is not good anymore. See, so these I got to bring out. So I could either erase it or we could do something else. We come back here, and the moment the engine is off, so right here, if this gives an error, it automatically goes to the catch. If not, it will do the next line. The next line being a confirmation. So this is our confirmation. Same thing goes for, let's say, start engine. Right? So if this gives an error, this line will be skipped and it will automatically go to the catch. But if this doesn't give any errors, we're going to go to the next line, which is saying engine started. Same thing for our takeoff. Let's go check out what I forgot. Here we go. I'm going to remove those. So no prints. And you'll notice here, let me put that there. You'll notice here the altitude doesn't exist. So we're going to do airplane, and we're going to create a getter if we haven't already. So in this case, get altitude, right? So here I'm the one who decides how to print this out. I'm the one who decides how the errors are being shown, right? Same thing for stop engine. Same thing for increase altitude. Again, you could see I forgot to do all of this. Now you could see over here, not only do I want to showcase the altitude, but I have the next state. So we're going to come back to this in a second. We're going to put some train of thoughts in there. So first we're going to put the confirmation. We're going to say airplane altitude increase by airplane class dot. It's not a static thing. So it's by my airplane dot and rate of change, altitude rate of change. There we go. And over here, we're going to do airplane get altitude. So we got our increase and we got to do our decrease. Let me go ahead and grab, actually, you know what? Let's grab this, put it there. And here we're going to put decreased. Good. And we could erase this stuff. Now, when it lands, so this check is to change the status. This I cannot bring outside. Status cannot be modified by outsiders, right? It's private. So this has to stay. But this part is an extra bit. So I need to check if the altitude is 0 and confirm that to users. So you could do a couple things here. I've seen some of my students return something to state of the airplane afterwards. So something you could do is to return an airplane status. That could have even worked. You could have even replaced all the exceptions with that airplane status. Well, not the exceptions. The airplane status is for exploded. Well, that works. Engine off, engine on grounded, flying. To be honest, you could have replaced all of these exceptions with that, and that would have been fine. If not, well, then you got to do the checks outside as well. So outside being right here. When I decrease, I'm going to say I decrease by this much, the current, and I'm also going to say if. To be honest, I like it better with the return, but we're not going to do it yet. And here we're going to say get altitude. If it's 0, we're grounded. Pretty straightforward, right? Now for the increase altitude. Ooh, did I forget to put that? Where are we? This is decrease. We have, where's my increase? I forgot to do the increase. I think I cut it out rather than copy it. So here we got our increase. And then we got to check again, increase. Again, we got to check which one of these it's happening. So let's go ahead and copy that. We're not going to erase it because those status change is done inside. But here we could say airplane get altitude. And does it equal to my airplane dot exploding altitude? Right? We do the same thing for our warning and for our checking the warning. Cool. Now we could have done something better here. Now here is a bit different because we're checking different altitudes and we get exploding altitude, warning altitude. We could send the status again and put one of those status being warning. So we could have added, we could have added a warning status here and so forth, so on, or we could have created another enum to make it cleaner. I'll let you guys manage that to not make this too long, but that's, as I'm doing this, that sounds much better, right? More readable. But let's come back to this for a second here. So now we have our confirmation, which is the next line, and we have any issues that could arise. But the problem is this try, catch, repetition is making our code much harder to read. So we want to clean this up. And we said it, if you notice that every case inside our switch, they have a break. So none of them is going to the next case after starting one of those cases. So what we could do, and especially since the exceptions are the same, and especially since we're only going to do one case at a time, we could surround our switch by the try and catch it outside. What does that mean? So this try, I'm going to bring it out here, put my switch in it, and this catch, we're going to put it right after my my switch. So here. We're going to do a Control-Alt-L so it cleans up our code because we extracted some stuff and now you notice the alignment is wrong. We're going to do Control-L, Control-Alt-L, and look at that. Now, if we look at our case is specific to what it needs to do. It's going to start the engine. If the engine breaks, it's going to go and catch it here. If it works, we're going to get a confirmation on our screen. And we're going to do the same thing for all of them. So here, we're going to remove this. We're going to remove these. There are some exceptions I haven't done with the first one, so we'll do it in a second. But you could see that it's going to become the same thing. Where is my exception? There we go. Now there's a lot of testing I'm not doing and I could improve it more. I just don't want to spend 2 hours explaining every step and correcting. So now we're going to do Control-Alt-L again. Our code becomes more clear. So start the engine, try based on that switch, based on the case, start engine, take off, etc., etc. So here we see that we didn't handle those. We're going to add the catch clauses for whatever we're missing. And it managed to handle all of them. And again, you see it's a lot of repetition, so we could do a collapse. And again, I don't want this stack trace over here. We want this thing. And there we go. So now this is the same thing. Let's collapse it again. The only problem I have with this, the only problem I have with this piping, it's long and you're going to miss out on some stuff, and it's okay. It's not bad. And if you wanted to, you could clean it out a bit, maybe saying, I'm going to put 2 lines per thing. So this could be nice too. But I find this again still a bit hard to read. One thing that we're going to learn a bit later is about polymorphism. I'm just going to show you like a little preview of that in the future. One thing we could do with all of these specific airplane, well, actually we don't need this one. One thing we could do with these airplane exceptions that we created is to say rather than catching this, we're going to catch the parent. The parent's going to include everything underneath. We're going to talk about polymorphism later. So the parent in this case is exception. So if I wanted to, bear with me for a moment. I'm going to do a little mistake first. If I wanted to, I could go here and say exception. And you could see that my compiler is okay with it because I'm catching those types of exception that will be thrown by decrease, increase, start, etc. because they all inherit from exception. The problem with doing this is that now we're catching other things that are deriving from exception. If we look over here, there's been a lot of classes that extend exception. And by catching all of these, we're causing unexpected errors. Again, this would become a logic error. So we don't want to catch every type of exception that ever came to be. What we want to do is catch only the airplane exceptions. So to be able to do this, we're going to create one extra class again. We're going to call it airplane exception. We're going to extend it exception, so it's a checked. And over here, we're going to, again, override the constructor and pass it to the parent. But now, having this class created, we could come to our airplane engine off and say we're extending not exception, but one layer in between. We're extending airplane exception, which extends exception. Same thing for this guy. This one is our airplane exception, so we're not going to touch it anymore. Exploded, flying, grounded, and there's this one, but we're not going to touch it because airplane exception is extending exception, so it's a checked exception. Runtime exception is an unchecked exception, so we don't want to merge them. Otherwise, now we have to handle this at a client level, at a developer level, right? We talked about it at the beginning of the video. So we don't want to extend this to airplane exception. We could make another class called airplane runtime exception, but we only have one of these, so we're not going to bother. So now what happens is, rather than saying exception here, we're going to say airplane. There we go. Airplane exception. Now we're only going to catch anything that derives from this airplane exception and not everything that derives from exception, which is a lot more, right? And in this case, one last thing we're going to do is to test it out. So I'm going to go ahead and test it on my own. Thanks for being here. I hope it made sense. Otherwise, message me and I'll deal with that later. Cheers.